Once thought to be a member of our nearby planetary family, Pluto is a far-off and confusing planet. But recent alarming claims by prominent astrophysicists Neil deGrasse Tyson and Michio Kaku have thrust Pluto back into the public eye with a startling revelation. They imply that this frigid planet is headed for a potentially violent collision with Neptune. However, what are the possible outcomes of such a massive catastrophe, and how might this possibly come to pass? Are we witnessing a fascinating, massive, and unmissable event? Or is there another factor at play here that could lead to a catastrophic mishap? Come see what may happen if Pluto and Neptune collided. The cosmic community continues to be interested in and research Pluto, a former planet that was reduced to a dwarf planet mostly due to its erratic orbit. According to recent estimations from top analysts, Pluto's orbit is dangerously close to Neptune's. Both Tyson and Kaku are warning of a possibly dangerous collision between these two planets, which might endanger Earth in a terrifying way. However, how could such an occurrence possibly occur? Pluto takes an incredible 248 years to complete one circuit around the Sun, which is longer than any other planet in our close planetary group. It has not even completed one complete revolution since its discovery in 1930. The fascination doesn't end there. Pluto's trajectory is distinguished by its extremely elliptical form, which differs greatly from the big planet's roughly circular orbits. Pluto's orbit is tilted 17 degrees to the ecliptic plane, which adds to its peculiarity. Pluto travels a far steeper trajectory than the other planets. Its circular shape and inclination give its orbital pattern additional layers of complexity. Contrary to what one might anticipate given their places in the solar system, Pluto actually approaches the Sun more frequently than Neptune for about 20 years in each cycle, making this one of the most fascinating aspects of Pluto's orbit. The obvious question that this raises is why Pluto and Neptune haven't collided. The gravitational pull of other planets holds the solution. Soon after Pluto was discovered, the orbit of the planet was investigated. Cosmologists first attempted to explain its peculiar trajectory. Pluto's eccentric orbit and steep inclination let it stand out from other planets whose orbits are slightly near the ecliptic plane. The discovery that Pluto's orbit does, in fact, cross Neptune's added to the puzzle. The complexity of celestial physics is demonstrated by the stability of Pluto's orbit in the face of these complexities. Determining how three celestial bodies, such as the Sun, Neptune, and Pluto, move and affect one another through gravity is known as the three-body problem. It's similar to attempting to forecast their future direction based on their starting points and mutual pull. This issue illustrates the intricate interactions between Pluto's orbit, Neptune's orbit, and the gravity of the Sun. The Kozai oscillation and the concepts of Amal libration and degree libration are essential components of this puzzle. Astrophysicists believe that Amal libration is what maintains all planets in their orbits. In the context of Pluto and Neptune, this phrase indicates that Pluto is approximately 90 degrees from Neptune whenever it crosses its orbit. In order to prevent their orbits getting convergent, this space separation is essential. Conversely, degree libration describes a celestial body's vertical movement within its orbit. This gives Pluto an additional layer of protection from possible impacts because it is positioned considerably above the orbital plane of Neptune or any other huge planet when it is closest to them. The Kozai oscillation, named for three scholars who researched object motion in space, Kozai, Zipper, and F, is another important component of this scenario. It describes the gravitational force that three celestial bodies, such as the Sun, Neptune, and Pluto, have on one another. They move differently as a result of this pulling. When it comes to Pluto, the Kozai oscillation explains why its orbit around the Sun is so unusual. Even though Pluto's trajectory seems erratic, this oscillation helps to maintain its smooth motion over long stretches of time. The Kozai oscillation demonstrates how some patterns and laws keep things under control even when they appear erratic and random in space. By keeping Pluto's orbit steady, all of these factors assist prevent it from colliding with Neptune or veering off track. We use this three-body issue to determine how these parameters vary depending on the forces exerted by these space objects on one another. We can learn more about Pluto, our solar system, and other far-off worlds and their stars by researching this. Despite these stabilizing characteristics, Pluto's orbit is essentially chaotic, with small changes in beginning conditions producing large variations over millennia, according to numerical models conducted in the late 1980s. Nonetheless, it has been discovered that over incredibly long time periods, these special characteristics of Pluto's orbit remain stable. But it's crucial to keep an eye on the pandemonium. We now have a better understanding of how the giant planets, such as Jupiter, Saturn, and Neptune, affected Pluto's orbit around the Sun because to later computer simulations. Neptune and Pluto have a unique relationship. Neptune completes 3 orbits around the Sun for every 2 that Pluto completes. Pluto's trajectory is kept predictable by this interaction. Neptune isn't the only planet helping with this, though. Jupiter's gravity is also crucial in keeping Pluto's orbit stable. Indeed, Pluto will remain on a stable course for a considerable amount of time, billions of years, even, due to Jupiter's powerful gravity alone. Therefore, it seems like Neptune, Jupiter, and Saturn are cooperating to make sure Pluto keeps traveling through space safely and trouble-free. In the larger scheme of the cosmos, these quirks are essential for preserving the regularity and orderliness of the motions of the planets. Our solar system would be far more turbulent and chaotic without these elements. Other celestial bodies may be impacted if bodies like Pluto are evicted from their steady orbits or clash with one another. Understanding Pluto's orbit is essential, especially in light of talks that it may crash with Neptune in the future. It helps us better understand how dynamic the solar system is. Pluto serves as an example of how the intricate interaction of orbital mechanics and gravity can bring even the most seemingly unstable orbits into balance. It also demonstrates how important it is to keep an eye on and study these phenomena in order to comprehend our role in the cosmos. Investigating the depths of space frequently compels us to face the irrationality of celestial bodies, and Pluto's orbit is a perfect illustration of this peculiarity. Pluto's situation exemplifies the idea of orbital chaos, which describes the sensitive reliance of a celestial body's trajectory on its beginning conditions. This implies that the dwarf planet's long-term orbit can be significantly altered by even little changes in its position or speed. Researchers have greatly benefited by using virtual simulations to determine Pluto's motion in space. These simulations illustrate the gravitational force between Pluto and other space objects, such as Neptune, using sophisticated mathematics. Astronomers can observe how even modest adjustments can have a significant impact on Pluto's final location by altering little details in the simulations. These models revealed something very intriguing about Pluto's orbit in the late 1980s. Its journey can be chaotic and unpredictable even though it is stabilized by factors like degree libration and AMOL. Over many years, Pluto's orbit can appear very different if you start with a slight variation in its location or speed. Pluto's orbit, however, stays steady for extended periods of time, billions of years, despite this instability. This indicates that, although initially appearing chaotic, Pluto's orbit around the Sun has some order. Future events are difficult to predict, particularly when they involve unstable orbits like Pluto. Because these systems are inherently unpredictable, long-term projections are frequently rife with uncertainty. Although numerical simulations offer a reliable way to comprehend and forecast how celestial bodies will behave in the future, they also draw attention to the limits of our capacity for prediction. The precision of the beginning conditions and the intricacy of the interactions they simulate are crucial factors in these models. Accurate forecasting is difficult since even a small mistake or distortion can have wildly disparate results. Furthermore, we are reminded of the dynamic and ever-changing nature of the universe by the chaotic nature of celestial orbits like Pluto. Even if our understanding of space has advanced significantly, the Pluto instance serves as a reminder of how little we still know about the cosmos. Gaining knowledge of the giant planet's gravitational pull on Pluto's orbit can help one better understand the dynamics of the solar system as a whole. It demonstrates how each planet's location can have a substantial impact on the stability and course of other entities in the system. Why, however, are well-known astrophysicists now voicing concerns about a possible Pluto-Neptune collision? Neil deGrasse Tyson, a well-known astrophysicist and a major contributor to the popularization of cosmology, provides a distinct viewpoint on the mysteries of our solar system, especially the fascinating case of Pluto, despite all these intricate forces working to avert such a catastrophe. Tyson, who is well known for having helped rename Pluto from a planet to a dwarf planet, offers perceptive analysis of how celestial physics is changing and how the general people is drawn to the mysterious worlds of space. Tyson's stance on Pluto's renaming stems from our expanding understanding of the solar system. He views the name as a major change in our growing knowledge of the many bodies circling our sun rather than a demotion. He takes a lifelong learning and adaptation approach to celestial mechanics. He sees the intricacies of orbits such as Pluto's as evidence of how much more space has to offer. The curiosity surrounding these issues, particularly the possible interactions between Pluto and Neptune, emphasizes how dynamic and frequently unpredictable our solar system is. His writings highlight the fact that as we learn more about space, new questions come up, encouraging us to do more research and deepen our comprehension of the cosmos. Physicist Michio Kaku is another famous. Focuses on the frequently erratic forces that shape our cosmos, providing a distinct yet complementary viewpoint on the mysteries of space. Kaku is a prominent figure in debates over celestial mechanics and its wider ramifications for humanity because of his reputation for bridging the gap between sophisticated scientific concepts and innovative ideas. Kaku's opinions on Pluto and its orbit highlight the necessity of ongoing monitoring and sophisticated modeling in order to forecast and comprehend possible astronomical occurrences. He believes that studying the interactions between heavenly bodies is important for both intellectual and practical reasons. For example, the hypothetical collision between Pluto and Neptune serves as a reminder of the dynamic and frequently turbulent character of space. Kaku's futurist viewpoint challenges us to think about the wider effects of such occurrences, ranging from how they might affect our knowledge of the solar system to whether more space interventions are necessary. His viewpoint emphasizes how crucial it is to be ready for anything in space. According to his research, our ability to navigate and maybe lessen the effects of cosmic occurrences will improve as we gain a greater understanding of the forces at action. Tyson and Kaku share the belief that space is a field of unending exploration and that, despite our current level of knowledge, it is still quite small. Their focus on the necessity of further research and sophisticated modeling is indicative of how space science is developing. They emphasize the significance of not just comprehending celestial mechanics in their current state, but also making predictions about how they might evolve in the future. A case study of the larger opportunities and difficulties in space exploration is provided by the possible collision between Pluto and Neptune. It emphasizes the necessity of thorough scientific investigation, cutting-edge technology, and a readiness to modify our knowledge when new data becomes available. Tyson and Kaku see the mysteries of space, such as Pluto's orbit, as a wake-up call for the scientific community and all of humanity to continue expanding our understanding. Because of their mean motion resonance and the different gravitational forces at work on them, scientists generally agree that Pluto and Neptune's orbits will be stable for many years to come. Therefore, it is extremely unlikely that Pluto and Neptune will collide directly. Nonetheless, because of the intricacies and possible subtleties in orbital dynamics, cosmologists should keep an eye on and research these celestial entities in order to gain a better understanding of their long-term behavior and any hazards they might pose. Even while the likelihood of a Pluto-Neptune impact is still mainly speculative and doubtful given what we currently know, it emphasizes how crucial ongoing research and observation are to space science. Technological developments, such as increasingly sophisticated telescopes and computer simulations, will help astronomers improve their models and forecasts, ensuring that we remain aware of the dynamic and always shifting nature of our solar system. Kaku's focus on the unpredictability of celestial mechanics and Tyson's viewpoint on Pluto's renaming both highlight the necessity of ongoing research and an adaptable conception of our world. Although it illustrates the intricate and dynamic interconnections in our solar system, the possible collision scenario ultimately serves as a reminder of the enormous remaining unexplored gaps in our understanding of space. We work to solve these puzzles via constant research and observation, making sure that our knowledge keeps up with the universe's constant change.